Okay, cool. So you've already seen a little bit about the gem5 resources. Sorry, give me 1 second. Okay, nope. Okay. So you've already seen a little bit about the gem5 resources, but now I'm going to go in and talk a lot more about it. This is one of the things we've been doing over the past couple of years that I think is one of the biggest improvements to the usability of gem5 in a while. One thing I'll say is, for those of you following along with code spaces, it probably went to sleep while you were gone. When you bring it back up, it's going to have to do this post start thing again. So go ahead and bring it back up and let it start thinking. Okay, cool. So gem5 resources. As well, maybe we haven't seen, but you might know that setting up these simulations is complicated. So when you're setting up a simulation, you need things like the kernel that's going to run on the disk, or kernel that's going to run on the system, all the operating system stuff, whatever libraries you want to use, whatever workloads you want to use, whether those workloads are annotated or not, the inputs to the workloads, etc. And this is a lot. So gem5 resources is kind of your one-stop shop for all of these things that you need to simulate. So for example, we were working with the x86 Ubuntu, I guess we were doing 2404 boot. And within this thing that's obtain resource, this has a lot of everything you need is kind of magically in here. So it has the kernel, which I think is like 5.15, maybe 6.15, I don't know, has a kernel in it. It has the disk image, which contains all of the stuff that you need on the disk, Ubuntu in this case, along with any kind of workloads you might want. It has the kernel command line, so the right commands to use to boot the kernel. And it has a script that you want to run after it's booted. So there are a bunch of different types of resources in gem5 resources. There's file resources, which include things like binaries to run, kernels, disk images, bootloaders, anything that can be in a file. There are directories, and so you can have checkpoints and sim points and elfies, as we saw, in resources as well. Then we have the idea of a workload. And so a workload is a combination of other resources, plus maybe some options that you use to run something in gem5. And then we just recently, in this release, introduced the idea of a suite, which is a set of workloads. So if you want to use the resources, the main way to do this is through this obtain resources call. And so if it's a workload, you can call board.setWorkload of obtain resource. This sets the workload on the board automatically for you, depending on what type of resource it is. So this works both in SE mode and FS mode. We'll see how in a couple of minutes. If you want to look at the details of this, I've given you the link in the gem5 repository for where this is implemented. And it uses kind of a weird software engineering thing of mix-ins, where we're kind of like mixing in these functions into the classes. It's a little bit weird, but it works pretty well. Any questions so far?
Questions? Not so far.
Okay, so before I dive into more details here, let's pull up the gem5 resources website. So on the site, you can search for resources. So for instance, say we want to look for Ubuntu. This will bring up all the different resources that match Ubuntu. You can also look for specific categories of resources. So for instance, maybe you want just workloads. So this workload is Ubuntu boot. Or maybe you want kernels, which I guess there's no kernels, but if we search for Linux, there's a bunch of Linux kernels. Or as we saw before, you could say search for all the elfies and see all the different elfies. You can also limit by particular architecture And some of these resources are only applicable to some versions. Let's see. What else do I want to say here? So if we look at these resources on the resource page, so for instance, a workload, since it points to other resources, you can see the other resources that this workload uses. So this one uses the OpenSBI bootloader and a 6.6 kernel and the 2204 disk image. Most of these should have a pointer to where it came from. So the source, you can click this link and see where the source is. And this is all the information about how this resource was built, what's on the resource, etc. So this might have multiple versions. So as we update things, these different resources might have different versions. There's how to use it, and also if you want to see the raw, what's in the database, you can see the JSON output of this as well. Okay, any other questions on looking up gem5 resources?
Any questions? You can go ahead, Jason.
Okay, cool. Okay, so talking about the set workload function, we actually have 2 or 3 different set workload. Well, there's actually a number of different set workload functions. And essentially the workloads in gem5 resources will automatically call the right function. So for instance, on this set SE binary workload, there's lots of options such as what the actual binary is that you're executing, whether you should exit on the work items, what the arguments are to the binary. And there's also this option for checkpoints to load in with the workload, which we did not see before, that I skipped over. There's a set kernel disk workload where you provide a kernel on a disk and an optional bootloader. And then the read file or read file contents, this is something that you can read in from the outside world into the guest system. And then you can provide a checkpoint here as well. So in these files, the documentation should describe how to use these functions if you want to create your own workloads. So you can also use local resources. So for instance, if you don't want to use obtain resource, but want to use something you compiled locally, you can just use binary resource with the path to that resource that you want to use. You can also even create your own whole databases of resources locally. So if you have a gem5 config.json file in your current path, it will use that to figure out which database to go to. And there's an example on this website down here under using local resources, how to do this. You can then have your own JSON file, which defines resources. So over on the right-hand side is an example. And you can use that raw tab that I was showing you on the resources website so that you can see the details of what you need to put into the JSON. Any other questions so far?
Doesn't look like it. Go ahead.
Okay, great. Okay, so workloads are the definition of like running one thing. And then suites are a group of workloads together. And so you can iterate over a suite. So you can say like for all workloads in the NAS parallel benchmark suite. And you can also filter these suites based on input group. So spec has like test, train, and ref. So you could filter everything based on just train or just test. And this is a pretty flexible interface for you to do this. And it should be documented on the web page what the different input groups are for each suite. Okay, so that's gem5 resources. So one of the ways that this is particularly useful, and this is also something that was just released yesterday with the 24.0 release, we've added a new idea of multisim. So the idea here is often you want to run many workloads. You want to run all the workloads in a suite, or maybe you want to run a bunch of different boards to do design space exploration. Multisim is a way to do this all in parallel automatically from gem5. So let's look at an example of this. So if we go to materials, ISCA 2407 multisim.py, we're going to use this getting started benchmark suite. So the way this works is you call this add simulator function, and you build up all the simulators that you want to simulate, and then you can simulate them all in parallel or one at a time. So let's look at how this works. So coming back over to my code space, clean things up a bit. So now we're going to do 0.7 multisim. So here we have this board, and let me just write what I had on that example on the PowerPoint. So we're going to do for workload in obtain resource RISC-V getting started benchmark suite. So this is a suite of benchmarks, and I'll show you. We can go look and see what's in them. So if we go to gem5 resources, getting started. So here's the RISC-V getting started benchmark suite, and here's the workloads. So we have RISC-V LLVM Minisat, BFS from GAPS, TC from GAPS, IS, LU, and CG, BT, and FT from NASPRL benchmarks, and also a simple matrix multiply. Okay, so those are the workloads in the getting started suite. So for each of these workloads, we want to take our board, set the workload to the workload, create a simulator with our board. And we're also going to set an ID for the simulator so we can keep track of which is which. We're just going to use the workload ID, and then we're going to call add simulator. So this add simulator came from the multisim package. And that's it. So now we've declared all the different simulators that we want to run. So this will run, so I think there's 9 workloads, so this will run this 9 times. So we can go to this directory, materials, ISCA. And so before we run this, we can run gem5 0.7 multisim. So if we just try to run it, I think this will give us an error here, because this workload is not meant to be run in gem5. So right, it gives an error running the script directly. We shouldn't do that. Instead, we should run it with this module. So we'll look at that in a second. So we can also use -L to list all of the simulators. Just had to do some downloading. I'll do this again to kind of clean that up. So here's all the different simulators, all the different IDs that we could run. So now that we've seen that, let's run this with the multisim package. So gem5 again is just like a normal Python interpreter. You can pass a module to it to run. So we're going to run it with this gem5 module, gem5 util multisim. So we're going to run this Python module, and then the parameter of the Python module is this Python function that declares all of our simulators. What did I type? What was my typo here? Oh, is it utils with an S? Yes. Okay, so we run that. And so it's going to find all the simulators that we want to run, and then it's actually going to run them all in parallel. And so since we have 8 cores, it's going to run 8 versions of this. So for instance, I can open this, and you can see we now have 8 versions of gem5 running. And if you look at M5 out, we have 8 different output directories, one for each of these workloads that's running. Is there a question?
I was just gonna ask, for those who are trying to run the tests along, do you need him to pause here to get the tests running, or are you all able to run exactly what you said? Folks are able to keep up? Okay, then mind. So go ahead, Jason.
Okay, yeah. So all of this is going to take a couple of minutes. So I think most of these take like 1 minute, but since we have 9 of them and only 8 cores, we'll run 8 of them in parallel, wait for the first one to finish, and then start running the next one. So if you look at what's in the gem5 out directories, so for instance, if we look at all the stats.txt files, it looks like none of them are done yet. So we can just sit here, wait for a minute for these to finish. Oh, it looks like, yeah. So these are running. At least when I did it yesterday, it was 1 to 2 minutes. Still running. So yeah, any other questions or anything about resources or multisim? The multisim is something that's pretty new, and so we kind of expect that this is going to improve significantly over the next couple of iterations.
Questions?
There we go. So it looks like most of them finished. So now we just have one that's running to run the last one. And if we look at the stats.txt, we actually have values in everything except for IS, which must have been, or everything but LU, which must be the last one that's running right now. Okay. There aren't any questions. I assume we're in our post-lunch lull here.
Well, I'll answer one question, Jason. I'm curious. So are you launching these like as different processes then? Like, because normally running a lot of gem5 instances on one machine, unless you have a giant server or something, is going to take up more memory than the machine has. So is multisim just kind of taking it and saying, oh, you want end process, so you end processes, or is it doing something else?
So we're using Python multiprocessing in the background. So yeah, it's creating a new process for each one of these. But it's in a way that we have a little bit more control. You can also specify somehow, I forget how, but you can specify the number of processors to use. So you can use fewer processors than your number of cores. In the future, soon, I hope that we will expand this to be able to use batch processing systems as well. So you can launch these to say Condor or using QSub.
Makes sense. Great.
Cool.
Anyone else? Any question while we're pause? Are folks having any problems running the same tests? Are you seeing the same things, Jason? Seems like it's running. So, okay, go ahead then, Jason.
Awesome. Yeah. So as I mentioned, this is a little bit different than your regular gem5 scripts, since we're declaring a bunch of simulators instead of just directly executing it. So you can also list the simulators, or you can run a single simulation by specifying the ID. Excuse me, by specifying the ID without the -m multisim part. So there's a lot of improvements coming. One of the things you might have noticed in my example is like the standard out over here is kind of a mess. You can make that a little bit better by using -RE. So to redirect the standard out and standard error, but that's still not great because Python multiprocessing is kind of weird with the way it deals with standard out and standard error. So we're working on that. And then what I really want to see, and I'm hopeful that we will be able to get this done over the summer, but we'll see. What I'd love to see is a dashboard. I would love to see for each of these simulations a time estimate for how much time is left, a way to check on the status of the simulation, a way to relaunch things that might have crashed for random reasons, because sometimes things crash. So that's something I'm hopeful will be coming soon.